Once again, please consult your textbook, Chapter 1, for definitions, as well as the lab manual, again for definitions. And in this part of the experiment, you're going to examine some elements and compounds, mainly the elements. As you know, from this table here of the elements, we have 118 elements. All have been found already. Now, here are the elements. Please note that in the lab manual, you're going to write down the state of the element: liquid, solid, or gaseous. And most elements tend to be solids. There are a few gases, and only one, as far as I know, just one liquid happens to be liquid mercury. So you write solid, for solid you write S, liquid you write a small l, and for gases a small g. Let's now look at some of these elements. I shall begin on this side with what we call non-metals. Non-metals. I have red phosphorus, I have sulfur, carbon, I have nitrogen, hydrogen, and oxygen. These are gaseous elements, these three here, and these happen to be solids. Please note that all these nonmetals, they share some common properties. For example, this device here can tell me if the element is conductive or non-conductive. As you can, it's a light bulb with two leads. So when I touch element sulfur, it is a non-metal, does not conduct electricity. The same with phosphorus, the same with carbon, the same, of course, we don't examine the gases because gases are non-conductive. But please note something interesting about carbon. Carbon comes in two types. One is called charcoal or coal. One is called graphite. Graphite. So coal, non-conductive, but graphite is conductive. So you see then it's a non-metal, comes in two types. In this case, I have two types. One is non-conductive, coal. One is conductive is graphite. The third allotrope is called diamond. It's a very shiny substance, also non-conductive. Let's now move from these non-metals and move towards some metals. Okay? Lead, magnesium, aluminum, silicon. I'm going to put silicon away for a while. Silicon, iron, nickel, cobalt, copper. See? Zinc, silver, tin, sodium, metal, and mercury. As you can see, all of them are solids except for mercury. The most important characteristics of metals are they conduct current. So let's try the same device again, same device. I'm going to touch the first element, magnesium, conductive. Lead, conductive. Aluminum, conductive. Iron, conductive. I don't have enough elements here. Cobalt and nickel also conduct current, as well as the element copper is a good conductor of current. I have two more elements. Silver element, silver. I'm going to take a piece of silver. Of course, you never touch the element. You have to put it on the bench top and then touch, otherwise you get a shock. and by touching the silver, it's also conductive. Okay? So metals tend to conduct current. They tend to be malleable. They can be ductile. It can be pulled into a wire, ductile. And so these are the common characteristics of metals. Now, when it comes to also another thing is called magnetism. Some elements are magnetic, such as iron. It can be left to the magnet, iron. And the same with zinc, not zinc, but magnesium, non-magnetic. But in this case, cobalt is magnetic, cobalt. And nickel likewise. Nickel, if I can find nickel here, I don't see it. But nickel and iron and cobalt can be magnetized. Okay. Now, it leaves now a class of elements known as metalloids. And the best example happens to be silicon crystal. Notice that silicon is shiny like a metal, but silicon is very brittle. If you hammer it with a hammer, I guess, you end up with you can fracture that like glass. So silicon is brittle. Also, silicon is non-conductive of current. See? So now we have three classes of elements: non-metals, metalloids, and non-metals. So in this report here, you enter the name of the chemical symbol of the element, its state, its conductivity, its magnetism, yes or no, and color or luster. And the last column, the nature, a metal, metalloid, or a non-metal. Now, there is one unique element here I'd like you to meet, the element sodium. Sodium is so reactive with air and moisture. It is kept under oil. I'm going to take a small piece of this element here under oil. I will allow the oil to drain on this paper here, oil. And then using a sharp knife, you can actually slice the element like this. So this oil here, once it is removed, if you cut it here, you end up with this shiny surface. It's a soft element. It's a very good conductor of current as well. So sodium is must be kept always under oil to protect it from moisture and air. And put it back here. Okay. And this concludes this lab and the section about the elements only. Next, we're going to examine some compounds, and the compounds are listed on page 217. I have a list of compounds, inorganic compounds. Some of them are binary, meaning you have two elements, like carbon oxide, and some elements consist of three elements. Some compounds consist of three elements, like zinc, sulfate, and so on. These compounds come in a variety of colors. This happens to be nickel nitrate, green. Copper sulfate, it is blue. Cobalt nitrate is kind of reddish. And these chemicals are either dissolve in water or they don't. So what we have done here, we have placed this chemical in a groups of two, one with and without water. You see, here is nickel sulfate crystals and the plus water. This tells you that the chemical is water soluble, will dissolve completely in water. The same with copper sulfate. Here the crystals in water is soluble. And I have here cobalt. A cobalt nitrate also is a solid, as you can see, it's a salt. It is purple. In water, it is soluble in water. And then some chemicals will not dissolve in water, such as copper oxide. Here is copper oxide, this gray powder, and in water, it remains insoluble in water. It will not mix with water. Okay, I have here a chemical called barium sulfate. Without the water, with the water, it is not soluble either. So right here, this chemical is insoluble, meaning not soluble. I have here zinc sulfate. It's like white crystals. In water, completely soluble in water. Okay, so again, you enter that on page 217. Okay, that's it for the compounds and the elements.